First case, so this is that ring. This is the voltmeter wires. These are voltmeter wire. And B bar is varying in this. Who can produce such a field? Solenoid. Radius of that. So let's not bother field, radius, everything. Directly has given the EMF induced in the ring is how much? 12 volt. Total EMF induced is 12 volt. Now, what is the method you brought? And B bar is varying. Okay, look at C now. The B bar varying in this magnetic field region. Will it produce induced electric field only in that circular region of radius C or beyond that? Yes, it will produce, no? And there's a conducting wire. So the induced electric field will also be present here. So now what this induced electric field will do? Will make the charges to flow here also, no? So the effect of induced electric field will not only on the ring, will also be there on this connecting wires and particular thing. So therefore the flow of charge here depends on what? Depends on induced electric field. Now what is the resistance? So we'll make a points here. So let this be the point A, C, B, and D. The ring is it's broken into two parts. ADB one arc, ACB one arc. So what is the resistance of those arcs? Let R be the total resistance of the ring for our understanding purpose. R be the resistance of total ring. And then what is RABC? Should be R by 4. What is RABC? Should be 3R by 4. Now what all EMF induced? 1/4 will be induced across ABC. And another 3/4 will be induced. What are the 12 volt? What we are saying, no? And what is total EMF induced across the ring? 12 volt for only ring. This is a background. Now you are going to connect to voltmeter. Now what is the EMF induced in ADC? What is the EMF induced in ABC, ACB? Total EMF induced should be E by 4. 1/4 of that will come. ACB should be E by 4. And the total EMF induced in ADC, ADB should be 3E by 4. What is the reading of voltmeter is asking. What about EMF induced in this loop? Where is the loop? There are two loops are there for you. There's a one loop, there's a one loop. What is the net variation of magnetic field here? 0, no? So no EMF induced in this loop. Net EMF will be 0 here. And we know EMF induced here E by 4. So there should be some EMF induced in this side. It should be equal and opposite. So I'll draw the circuit here. It will be like this. 3R by 4, 3E by 4, or you do one thing, if you want to write it. How to give the polarities for the cell? This should be E, A, B, C. Then there's a voltmeter will come. It's having high resistance, so there's no resistance of voltmeter. So in place of voltmeter also, I will bring one cell. This is a voltmeter. EV1 I'll call. This is the first case, no? This is the first diagram. Or write V1. No, no EMF should be induced in the loop, no? So what should be the value of EV1? EV1 should be E by 4. Should be equal to EACB. The magnitude of EV1 should be equal to EACB. So what is EACB? Should be equal to E by 4. And this is equal to how much? 12 by 4, 3 volt. Are you able to understand? So, sir, why you are equating this? No EMF induced in this loop. So therefore, when you trace it out, EACB plus EACB minus EV1 should be equal to 0. This EMF should be equal to this one. Then only the net EMF here will be 0. No current will flow here. Open circuit. Now, next again, come for the other diagram. So similarly, like this, you try to think. Actually, I should not show the circuit diagram to make you understand. I've just brought that idea.
Sir, in this case, why are we taking the resistance, sir?
Just wait. Resistance of the ring is needed, no? High resistance, there'll be just, the ring will have resistance, no, there. So if you call that a ring is not having resistance, then only EMF is what is discussing. Just I gave a circuit diagram. Huh? I would have directly said answer 3 volt. How 3 volt? How I should explain?
In this case, EV1 will be less than 3 volt now, sir.
Constant EMF of 12 volt is induced in the ring. Voltmeter of very high resistance is used to connect. You mean to say there'll be current I will flow, then potential
Through the
drop is there
resistance, yes.
to the resistance. There's a circuit diagram to make you understand. So the net EMF induced will be this much.
Okay, sir.
This is only for your help. It should, we have to think like this here. If we mention specifically resistance of the ring, something, and voltmeter of very high resistance. So no question of current flows in this voltmeter. That's ruled out. So actually it will read this particular potential drop here. So then resistance of the ring, if you take negligible, no, then it will read only equal to this much. Nobody has not mentioned. In both arrangements, the ring and connecting wires are in same plane. He has only mentioned that. Nothing else is there. Resistance of the ring, you take negligible. If they give resistance of the ring, then we should not write 3 volt less than that. Am I right? Because the current will be flowing. Will be different, will not be 3 volt. You have to calculate that potential difference, that you have to show it. We do have some problems like that also. That's why just I brought it here. No, I think the diagram. Next problem, with resistance only, I'll give it. It'll be easy for you. Why this is not coming? Yeah, we'll wind up here now. No, check it in similar way. So where the voltmeter will be connected at other ends. No, oh, I'll move down. No? Space not sufficient. There's a figure 2. They should not be there. The wire is connected. Voltmeter V2. Is it okay now? So second diagram. And B bar everywhere into the plane. The same situation. A and this is B. Okay, now work out how much it should be. The net EMF induced in this loop should be 0 because no magnetic field is linking, and this should be equal to E. So 1/4 of this, the equivalent circuit should be EV2, resistance of this 3R/4. And this is, previously it was, okay, 3AD. EADB, and this is EACB. Okay, now check it here. It will read how much. EV2 should be equal to 3E/4. So 3, 4, this is 12 volt. 9 volt, the voltmeter will read. This is a very dangerous thing that happens when you get into the lab. This is what happens here. So when you are working out with the magnetic materials and that the magnetic field is varying, no, the induced electric field will come into picture. So what actually we did, the wire, no, how you connect the wire from A to B, that will determine the reading of voltmeter. How you connect, and the wire and the particular ring are lying in same plane. Again, if you change the orientation of wire, things will be a little bit different here. So directly the voltmeter is I resistance, voltmeter is connected, no, so therefore it will just read, no current will pass through the voltmeter, this one, and ring also open, you can assume it to be of low resistance or high resistance. Better say high resistance, no current flow, so therefore it is reading that one. So for many of you are getting confusion, let me put very simple way. Resistance of ring is very high. So then what happened to current through the ring? If there is no current flow, then voltmeter will read EACB only. Fine, this is, I'll just make that addition. So here only I'll write it. Huh? Because we have next problems where the loop will have a resistance. So therefore, let's have that basic things properly here. Okay, fine, resistance of ring is very high. So now how that wires are connected between A and B matters a lot. Now if I bring the wire like this, it will read one value. If you connect the wire like this, it will read another value. So whenever you are dealing with, say like a magnetic materials means something solenoid, toroid, everything. And if you're measuring any voltage, and if B bar is varying, and if you're trying to measure any voltage potential for any other thing, no, you have to be very careful. Therefore, this particular diagram is what indicating. So this you do get plenty of problems. So how to say that no EMF induced in the loop? So you can say EMF in this loop non-zero here, in the ring non-zero, no EMF in this loop. Fine. So the net EMF should be zero. So what are EMF induced ADB? They should be equal and opposite to across this one. So the voltmeter will just read equal to that EMF. So EMF induced in this loop is zero. Here it will be non-zero. Like that, you'll get some connecting loops. In books, what happens? You have maximum only one loop is there. So I can bring connecting loop. Means what is the general idea of such problems? Means if you get a, if you are like this, so slowly what happens? You should develop a more generalized. This is the region in which magnetic field is present. I can bring one loop like this, and I'll connect one resistor also here. Clear this. Then I can bring another loop. I'll keep it here. It will have resistance, of course, all this. But B bar is varying here only. What about EMF induced in this loop? So I'll give the number 1, 2, 3. Altogether we have 3 loops are there. There's no EMF induced in the loop 1. Net EMF induced in the loop 1 should be 0. So and here B bar is present only here. What about EMF induced is a partially is there. Only this area of this sector S into dB by dt. Area of this sector into dB by dt is the EMF induced in this loop 3. So what about this? This should be no net EMF induced should be 0. What all EMF produced here, equal and opposite will produce in this side. So you get more than one loop also in induced electric. You have to be careful. Our books confined only for one loop. More than one loop also can come. Tomorrow I'll continue with some problems related to this. Okay, fine. So yeah, thank you. Any doubt related to this topic, you can clarify. I'll wait. That's what, no. See, so I should generate idea. See, I'm not bothered just like some no EMF induced in this loop. I should generate that idea, no. You are bothered about answer, I'm bothered about concept. There is only difference. I'm saying no EMF in this loop because no magnetic field is present. EMF is induced in this loop because field is present. That's what I wanted to generate that idea. How the net EMF induced will be 0 because there is EMF produced here proportional to length. So equal and opposite will be produced here. So therefore net will become 0. This is what we should think. Later on, okay, mathematically you're writing this voltage, this should be equal to this. Talk in terms of EMF induced in the loop. No EMF here, net EMF will be 0. Here net EMF is non-zero. So what all EMF induced in this, equal and opposite should be in this. That should be, that idea is what I should generate. No? no EMF, no net EMF. Okay, all of you. Bye. Take care. See you. We'll meet tomorrow again.